In this video, we're just going to talk about the properties of inverse trig functions, specifically how the inverse trig functions work with their regular functions and allow us to spit back certain numbers. So in this case, I've written down all the possible properties that we could work with, the sine, the cosine, and the tangent functions, as well as their inverses. And you'll notice here that there's a very specific set of domain values that each function is defined on. So the sine of sine inverse equals to x. These two functions will allow themselves to cancel out if and only if the x value that I'm plugging into the inverse trig function is between -1 and 1. Again, remember how we've defined the inverse trig function, so the values that we plug into here will only spit back these numbers. This is also true for the inverse sine function of the sine function. I can spit back numbers in here, and I'm going to get back an x value. This is not necessarily true if the values here are not in the values between -pi/2 and pi/2. For instance, if I were to plug in 3pi/2 to this location, well, the sine of 3pi/2 can be evaluated, and it would be evaluated to a number on the range from -1 to 1. But then the -1 to 1 value, whatever it is, will be plugged into the inverse trig function, and that inverse trig function, remember, only spits back values between -pi/2 and pi/2. So again, it's really, really important that we focus on what these functions can actually take in, and therefore what values that these functions can actually spit out. Because again, remember, when we plug these numbers in, they get plugged into the intermediate or inside function. The inside function does what it needs to do to it. Then the outside function will actually evaluate it and spit back a number. So this is only true, equaling to x, on this set of values. We can still evaluate this for other values. The only change is that it's not going to spit back the exact same number. Again, with how we've generally defined sine inverse, it will only spit back x when it cancels each other out in this range of values. You'll notice here then this is also true for cosine. Notice how this one here is only defined between 0 and pi. The specific set of values such that the cosine inverse will spit back those same numbers. Okay? If I plug in again a value in for x here, an angle, say that's 2 pi, cosine of 2 pi is going to be a value of 1, but the cosine inverse of 1 is going to spit back an x value, an angle measure of 0 radians. So again, this is only definitive on this set of values, but I can still continue to evaluate a cosine inverse of something cosine depending on what value I'm plugging in here. Let me go ahead and come up here to this one and go ahead and pick an example for this. Again, I can pick any number between -1 and 1 for cosine inverse, but the minute I start picking values that are not in that range, the cosine inverse can't evaluate them. Because if you recall, the cosine inverse is supposed to be as though it's an angle measure, which means that I need to pick an angle measure for cosine where I'm going to get back a value larger than, let's just say it's 2. I'm going to get back a cosine value such that when I plug in an angle, I'm going to get a value of 2 back. Well, that's physically impossible unless the original function was multiplied by 2. So if I try to plug in 2 to this, this whole thing breaks down. And that's the difference between this form and this form. And that's also true for sine. Again, sine inverse of 2 doesn't make any mathematical sense. It is unevaluatable. The sine inverse function is not defined anywhere outside of that range. When we look at the tangent function, this is also the same kind of case. We're working from -pi/2 to pi/2. On this function here, it's true for all values because tangent is one of those functions that are defined everywhere in terms of x and y. So we don't have any problems with this form of a function. Again, this one here, you got to be very careful when we're plugging numbers in. We can evaluate the tangent of that angle, and then the tangent inverse of that angle is going to send it back to a value somewhere between -pi/2 and pi/2. Also make note of all of the ranges, all the sets of values that we have here. These are all brackets. The brackets are there for a reason. This one down here, it doesn't have brackets because remember, the tangent inverse function for its y values are not defined at -pi/2 and pi/2. Those are the asymptote values. So again, this set of values all make sense, but for tangent, that's the only giant change in the tangent function where it doesn't actually get defined between -pi/2 and pi/2. But that's the major properties of sine, cosine, and tangent with their inverses, and how composing them together starts to work with those rules.